So we've already done some preliminary work for Chapter 9, so we're now going to go through Chapter 9 in a section-by-section basis. First section is we're going to talk about graphing the equation y equals ax squared plus c. And we're going to want to understand how those graphs relate to our y equals x squared graph. And we're just going to put information into our data table and come up with the 5 numbers that we came up with before. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 and then 4. If we know where the vertex of our graph is, this is where I came up with the over 1 up whatever the number in front of the x squared is. And then over 2 up 4 times that number. And this is our basic parabola. Okay, basic parabola. Things to point out: if a is greater than 0, I'm going to call this opens up. A is less than 0, it opens down. Okay. If the absolute value of A is greater than 1, we're going to call this a vertical stretch. I'll put that as a number 1. And the way we're going to see this on our graph, it's like taking these two arms and just stretching them up. So that will end up with a skinnier graph. And if the absolute value of A is between 0 and 1, it is a vertical shrink. And this would make our graph wider. So if, let's say this is a half, you could think of it pulling down these arms and it's going to graph wider, and we're going to see examples of that. The plus c, if it's in this form without that middle b term, if it's a plus c, the c is the vertical shift of the graph. And remember that this is going to be our y-intercept. There is no b term, so our vertex is going to be on the y-axis. So that's something you may want to note. If b is equal to 0, then vertex is on the y-axis. So this information should already be on your Meet the Parents paper that we did previously. And you really want to understand these. Okay? Now what I'm going to do is I'm going to pause the video, erase some of this stuff, and then we're going to graph some of the examples from the textbook in this section. So the only 4 examples that I'm going to do for this section are y equals negative 2x squared, y equals 1/3 x squared, y equals x squared plus 3, and y equals negative 1/2 x squared minus 2. Okay? If you know where the vertex of the graph is, you can use the rule that I talked about previously, which is over 1, and then go vertical that many units, then over 2, and go vertical that many units times 4. Okay? If you don't remember that rule, you can always plug numbers into your equation. Okay? I said on a parabola, we have to have 5 points to graph it, one of which is the vertex. None of these have a b term. So we know our vertex is always going to be on the y-axis. So the middle number I'm always going to want to pick is x equals 0, which is the y-axis for this type of problem. If the vertex is not on the y-axis, your middle number out of the 5 is going to be the one that is the x-coordinate for the vertex. And we're going to cover that again in future videos. You can always put points in. Find your x and y coordinates that way. Okay, so if you don't want to remember the rule for the shortcut, we put points in. Well, I'm going to show you an easy way to put the points in. If you know these 5 numbers, and there is no b term, let's look at the top one. Y equals negative 2x squared. So let's just make another column here. Negative 2x squared. This says take whatever number this x is, square it, and then multiply by negative 2. Well, I've already got x squared here. So all I'm going to do here is I'm going to take each of these numbers and multiply it by negative 2. So that would be a negative 8, negative 2, 0, negative 2, negative 8. So I'm going to graph that. I'm going to graph it in orange. So I have negative 2, negative 8, negative 1, negative 2, 0, 0, 1, negative 2, and 2, negative 8. Notice that it has the exact same shape as my parent function. This is y equals negative 2x squared. But it is skinnier. So the way I would describe this is y equals x squared, flipped vertically, and has a vertical stretch. Okay, so if you want to give it, you need to be able to give it verbal descriptions of how it compares to y equals x squared. The next one is y equals 1/3 x squared. So again, if I know where the vertex is, I can go over 1, up 1/3, over 2, up 4/3. So that's one way you can do it. Or you take your point, 1/3 x squared says to take each of the numbers in this x squared column and multiply it times 1/3. So that would be 4/3, 1/3, 0, 4/3, and then 4/3. Okay, you're going to notice here that my graph is going to be a lot harder to deal with. If I go over 1, up 1/3, over 2, up 4/3, and same way here, this graph is going to look something like this. Okay, I know some of you have problems with fractions. Okay, if you want to find a point that will exactly end up on one of the coordinates, one number you can always put in is the number that's the denominator of the fraction. Okay, but again, you may end up with a very big number afterwards. So let's put a 3 in here. If I put a 3 in, this will get rid of my fraction. Put a 3 in, 3 squared is 9. And 9 times 1/3 is a 3. So I'm going to plot the point 3, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So that's how to get a point that's exactly on a coordinate, is to put the denominator of the fraction in, and you will get something that's on an actual coordinate that's integers. That may be something that can help you out. Okay, again, it's not required. I only need 5 points. And as long as you show me your points and they're semi-accurate in there, you're going to get full credit for these. Now this is the same as the y equals x squared graph, but it is wider. So it has a vertical shrink to it. So it is wider. Next graph I'm going to do is x squared plus 3. And again, if you know what x squared is, all you're going to do is add 3 to each of these. So 7, 4, 3, 4, 7. So what I'm going to do is, I'm going to start at the middle. That's 3. At 1, I have 4. At negative 1, I have 4. At 2, I have 7. And at negative 2, I have 7. This is the exact same as the blue graph, or it's supposed to be the exact same as the blue graph, but it is shifted 3 units up. And my last example is going to take all of these into account. I'm going to do this one. I'll do this one in blue. This right here, the negative, says it's going to flip upside down. The -2 says it's going to move down 2 units. And this says it's going to have a vertical stretch. I mean a vertical shrink, because I'm multiplying it by 1/2. I'm going to put -1/2 x squared minus 2. Take this number, divide it by 2. That gives me 2. Put a negative sign in front of it is -2. -2 minus 2 is -4. -1/2 minus 2 is -2.5 or -5/2. Put a 0 in here. This term is 0, so that would just end up being a -2. And because I'm symmetrical about the y-axis, I can just copy these other numbers down. So I'm going to start again at the middle. 0, -2. 1, -2.5. 2, -4. -1, -2.5. -2, -4. So there are the examples of these graphs. Okay, I'm going to take that equation, -1/2 x squared minus 2, and notice that if I put a 2 in here, which is one of the numbers I already put in my graph, I did end up getting an integer. Okay, so if you want an integer values, you want to put this number in that will give you one of your integer values. Okay, so make sure that you deal with that. Now that's only if it's in this form. Okay, the paper that you're going to do your practice problems on has a graph of y equals x squared already on it. Okay, and then what you're going to do is I want you to graph four of the practice problems on each side of that piece of graph paper. And then you'll go to the other side, graph 4 more of them when you do your example. So you're going to end up with 2 sheets of the graph paper to do the 16 practice graphs for this. There are no take-home problems from the video. When you come into class, I'm going to have you graph one of the equations like this at the beginning of class, and then we'll do practice work.